you ready? All right, we're going to talk about immutable infrastructure today. Quick introduction. My name's Kyle Nearing, for those that don't know me, which I think everybody does. I'm one of the release engineers, been doing DevOps stuff for about 3 to 5 years now. So the first thing I'm going to talk about is actually mutable infrastructure and kind of go over what really a mutable infrastructure is. A mutable infrastructure is infrastructure that changes. It mutates over time. Typically, this is one of the types of infrastructure that you see most commonly. It has pretty much existed since the beginning of time, where people have long-lived servers. They're constantly making tweaks to their servers, and they have a tendency to kind of treat them like pets. You've maybe heard the term treating your server like cats or cattle, which this is where you're treating your servers like cats. It makes it kind of hard to scale horizontally because it takes a lot of time to actually build these servers up, get them to where you want them to be, provision them, and then also manage them, and basically just replicating these. It makes it a lot more difficult to actually do that. So there was actually a few things that were created to make this a little bit easier. Before, you'd manually go onto these servers and install packages, configure it how you want it, or you'd run like a bunch of shell scripts to actually get it to where you want your server to be. So that's where configuration management came into play. And I'm sure a few of you guys have actually heard of what we use here at CARS for configuration management, which is Chef. There's also Puppet, Ansible, and SaltStack. These are the big players in configuration management, and they've all got their, I guess, advantages and some disadvantages. For instance, Chef, one of its biggest disadvantages is that the servers have to call into a central server to be able to get the information on how it's supposed to look, how it's supposed to be configured. Where Ansible is, you take the configuration and push it out to all of the servers, so you're a little bit more in control and you don't have that overhead of a server that's got to actually hold all that configuration information for you. So configuration management, when it came out, it started to make it a lot easier to set up these servers exactly how you wanted them, and it allowed you to configure and provision all of these servers as code, which was a huge advantage and one of the biggest movements towards DevOps that there is. You'll hear infrastructure as code quite a bit, and this was one of the first steps towards that, is getting everything in code, being able to version it, and being able to roll back your servers to however you wanted them to be. But there was still a couple disadvantages of some of these configuration management tools, where you still have your long-lived servers. You're still treating your servers like cats. And one of the other things is that you're still making these changes after the server's been brought up. So you'd have a basic like Linux box of maybe CentOS or Ubuntu, and you'd bring it up, and then you would run all of these configuration management tools on it, and it would provision it to exactly the state that you want it to be in. But then over time, as people are making changes to this code, it's going to mutate how that server is. And it had a lot of drawbacks in that, which I kind of touched on a little bit earlier, where it's harder to scale them out. You'd have to set up the server, let these things run on it, and that's a lot of extra time. So it could take, sometimes our Chef client runs take 5-10 minutes to even run on a single server, where you could potentially bring that quite a bit down when you get into an immutable infrastructure. So what is an immutable infrastructure? It's basically your servers, they don't change. They're you treat them as an artifact. You treat them in a disposable way. So everything is set up and it's basically like an image or a snapshot of a server, and it's set up exactly how you want it to be, which makes it a lot easier to scale it out because all you have to do is spin up another instance of it and it's already configured to how you want it to be. So what is really needed to pretty much have an immutable infrastructure is Docker. It's not necessarily needed, but it does make it a lot easier because then your applications are immutable. If you attended Deep's talk earlier today, he talked a lot about Docker and kind of how it's treating them as containers, and you're treating your application as a container, and you just basically can run it on pretty much anything that's got that Docker engine on it. The next thing that you would want is a tool called Packer. What Packer does is allows you to kind of take all of this information and push it all together. I'm actually going to go a little bit more into depth on a lot of these things in just a second. There's also Terraform for actually building out the infrastructure, and then you're going to want a way to actually configure the servers. So you're still going to want that configuration management piece, which can still be Chef, or in simplicity state, you could still just use bash scripts, because one of the problems with with bash scripts was that they weren't idempotent, which meant that if you ran the script multiple times, it would try to do the same thing each time. And Chef and all these other ones solved that problem, where it was able to know the current state and check to make sure that it met these policies and these guidelines on how the server was configured. And if it didn't need to change something, it wouldn't. So that's one of the big advantages to the configuration management, but it's not necessarily needed in an immutable infrastructure because you're only going to run it once. So let's talk a little bit about Docker. I'm not going to really go too much in depth on it. Docker is just containers for your applications. They're immutable images, and it's basically got everything that you need for your application to run. So that takes a lot out of when you're configuring up these servers, the things like your Maven or Ant or anything that you need to actually build out these applications, or even having the dependencies for your Java applications living on the server. You don't need that stuff. You don't need Tomcat on the server. You basically just have all that stuff running within Docker. So then Packer. Packer is a tool for creating images or snapshots of your servers. It's also known as pre-baking. You can use it with a multitude of provisioners, which are like your configuration management tools like Chef, Bash, Ansible. There's tons of them out there that you can actually use to get the servers to the state that you want, and then it basically just takes a snapshot of it. One of the big advantages of Packer is it allows you to layer your servers in a similar fashion to how Docker works, where with your Docker files, you have a from and a base image, and then you build upon that base image and maybe make another image, and then you have another thing that's going to use that image and build upon that. So it allows you to layer your servers in a similar fashion, and also version out your servers themselves as images. And it's very customizable. You can actually have it build out for AWS, the AMIs on AWS, VMs for vSphere, Vagrant boxes. You can even have it build Docker containers as well. So then, once you've got your images and everything, you're going to want a way of actually getting it out to everybody to see. And that's where Terraform comes into play. Terraform is a tool for building and changing and even versioning your infrastructure itself. So all of, like your networking, how your servers communicate between each other, if you're using AWS, like your auto-scaling groups, your elastic load balancers, everything that you could need, you can use with Terraform to set that up for you. It is truly the infrastructure as code, compared to Chef, where its configuration is code. And it gives you nice execution planning, so you can actually get kind of a high-level view of what your entire infrastructure will look like before you actually go through and push it out for everybody to see and use, okay? And it's really easy to use. It's not very difficult. Their API documentation's really well done. And it's not limited to just AWS. You can use it to spin up your infrastructure on Azure, the Google Cloud, the vSphere, so on-prem. This also works as well in that situation. And one of the cool things too is Terraform is really new, so there's a lot of improvements that you can actually make, which I've made a few improvements for our use cases here at Cars, which you guys will probably actually see a little bit in the demo itself. So what do you need to kind of bring it all together? It's as simple as you pre-bake out your Docker hosts using Packer. So you get your image of your Docker host. You use Terraform to spin up that Docker host. The developer works on their application using Docker for their local environment. They finish what they're working on, they push it. Jenkins takes that, builds out the image, and puts it in the registry. And then we deploy the Docker application to a new Docker host using Jenkins or some other orchestration tool. So now I'm actually going to get into the demo, which should be fairly interesting. So just give me 1 second to pull up my terminal here. All right, so there's a few things. We're going to go through kind of Packer, how that looks, how you set up to build out an image, and kind of layering some of these images that you might have. So if we do a list on this directory, you can see that I've got, can everybody see that? I can make it bigger if you need to. So you can see that I've got this CentOS 7 base directory here, and then I've also got a console one, which you guys can ignore, and CentOS 7 for Docker. So let's take a look at the base image that we got. And it's super simple because it is just a JSON file, and then I've got a shell script that helps me actually provision it a little bit to how I want it to look. So if we take a look at the JSON file, let me actually just get rid of this. All right. So if we take a look at the JSON file, you can set some of your variables that you'll use throughout your Packer config, such as like your AWS access and secret keys, and the version that you're wanting to set this image to. I'm using environment variables, so I've got that set in my actual terminal, my bash, and it just pulls that from one of my environment variables there. And then the next thing is your builders. It's just a list of different builders. So you can actually have this build out in parallel image for AWS, for vSphere, for Vagrant, for the local developers. You can build out multiple things at the same time, and you just basically set your base there. So this example is building out for Amazon, AWS. There's a little bit of stuff that I probably won't go into because it's more AWS specific, like which VPC and subnet you want this image to live on. And then you're just stating, like, this is my account that I want to use to build this into, the region. And the most important here is the source AMI. I just basically Googled for a CentOS image from AWS, so this is one of their public images, and it's just a base install. Nothing else is really on there. And then I also set the AMI name. So when you go onto the AWS management console, you would actually see this in there called CentOS base, and then whatever version I set when I build out the actual image. And then you've got your provisioners. This is where you can put your chef configuration, so which cookbooks you want to use, or in this case, I'm just doing some inline shell scripts. So I'm just doing the yum update, installing unzip, wget git, jq, and actually this shouldn't be in there, but docker compose. And then I've also got a shell script that I'm just pulling in from the same repo to use to actually install the AWS CLI tools. So I could have put that in an inlet, but this is kind of an example of how you can use a shell script to work with that base. So after you do that, it's just as simple as running a Packer build and setting the version that you want and stating which JSON file you're going to use to actually build it out. I'm not going to actually build it out because this will take like 10 minutes, but the idea is that it does all of this prior to the server being set up, so we don't have to worry about when maybe, let's say we need a new Docker host. We don't have to wait 20 minutes every time we want to spin up a new Docker host. We only have to do it once prior, and then it's already set up in that way. Okay, so it'll build out the AMI, and then it'll actually output what the AMI ID is. So you can take that as your new base, for instance, for the Docker image. And in here, there's just another docker.json. So docker.json, and it's almost identical. You got your variables where I want it to be, but this is the new source AMI. So I'm just going off of that base that I built out, and I'm going to install some stuff on top of it. So I'm going to add the private yum repo for Docker to be able to find that and install it just from doing a yum command or a yum install. And then also my Docker conf for when I want to have it start up whenever so the Docker daemon will start up whenever I boot up the server. Okay, and then this also is just another shell script to actually just install those things and move them to where they need to be on that server. It also creates the Docker group and the Docker user. There it actually adds the CentOS user to the Docker group so it can execute the Docker commands. And then it just starts it. So this is actually really quick because that base is already built out. You don't have to wait for that yum repo or that yum update to run because it's already ran, at least at that point in time. It's already ran, and you can just do your yum install, and there you go. You've got Docker installed on this new box. And it's the same command for the Docker build, or the Packer build. You just give it the version, and it will build out that AMI and give you back the AMI ID. But you don't really need to worry about what that AMI ID is because it's also already on AWS. It spins up an AMI, or spins up that base image on AWS, and then runs all the stuff that it needs to, and then takes a snapshot of it, creates a new AMI on AWS for you. So from there, that's where kind of Terraform comes into play and allows you to spin up this actual image. So you can see here, I've got the Cars Terraform project. All of this is stuff that we are actually using at Cars now. I'm using it to set up our current Swarm and console clusters and doing it in an immutable way. So with this, Terraform out of the box, whenever you run any of the Terraform commands, it just looks in the current directory that you're in for these .tf files. So you can see in here I've got a main.tf, but there was issues where there was a lot of repeated code that Terraform would kind of have because they didn't have a good way of managing that state for different environments. So I've created a way that we can actually manage multiple environments in multiple states and also abstract out our modules. Okay, Google Hangouts wants to start up. And so it abstracts out the modules into a repeatable way as well. And I'll kind of show one of those. So let me go back to directories. All right, so we can see here we've got this cars Tech Tailgate that I created for this demo. And inside here, it's just got more Terraform files. And the main entry point into all of these is going to be my main. So that's where all my logic's going to be. And this is basic, on the right here, this is just basic Terraform script. So it's just saying that I want to have an AWS instance, and I'm going to call this instance master. So if I want to refer to it at any point throughout my infrastructure, I can just do aws.master, and it will refer to this resource itself. So it also gives you some outputs that you can get, like the private IP address of that instance, which you can use in other resources, so passing it to other resources as well.
Can you have multiple aliases?
For the same instance?
Yeah.
Not that I know of. But it's not really necessary. You basically, if I wanted to spin up 2 instances of this, I can either add a count to this, and it'll add like, so when you reference it, you can actually just put like the index for it, so 0, 1, or whatever you need, or you can just basically copy and paste this and just give it a different name, and you can reference it that way. So as you can see here, I'm not actually stating what the AMI is that I'm using. This is a module pattern that I'm using. I'm not stating the AMI that I'm using. I'm not stating the instance type, but I'm putting it in a way that I can override this information. But you see the VPC security groups is actually something it doesn't say var dot. So that's something that is actually being created within the module, and then I'm referencing it. So you can see I've got sg.tf, get rid of that, and it's just creating this AWS security group. I'm also calling that master, so I can reference that by doing the AWS security group.master, and I can also get its ID and pass it into the other, to that instance resource. This is super insecure. I'm just opening every single port, so don't do that. So with that, I'm able to commit and push this module to Git or Bitbucket and version it on its own without having to worry about repeating that code. So then you come back into your environments. This is where you're going to actually be running all of your Terraform commands. You wouldn't actually run your Terraform commands on your modules. And so one of the biggest things that the problem was getting that module. Normally that module would live in, like right here, there's a directory called modules. Normally you would keep it inside of that directory, and you would have to repeat all of that code for each environment. So I created a thing that I'm calling the Terra file, and it's just a basic YAML file. So you state what the module name is, so you could call it anything you want. This is how you'll reference it in the code. This is actually how it will pull that code down into what directory, and where you can find it. So where is this at in Bitbucket, and then what version. So I'm just pulling from master, but if I had a tag on it, I could do 1.0.0, and it would pull that code from that tag. And that's kind of the big plus to this, is that I can have different versions for each one of my environments. So let's say we're actively working on a Swarm cluster, making changes to it in dev. I can have it at the latest and greatest, but I can still lock down my prod environment to one that we know works. So 1.0.0 would be what's actually using that module in prod. And to get that to work, I had to create a rake file, which is just kind of like a Gradle file. It allows you to do some tasks. So it's just basically reading that and checking out that code into that that modules directory. And that modules directory does not go up to Bitbucket, so it's part of the git ignore and doesn't actually live with the repo itself. And then you've got the initialize. So initialize.sh I run every time before I'm about to do my Terraform apply. And what it does is it pulls down those modules, it invokes that rake file task, and sets where to find my state from Artifactory, because I'm storing that state of the current infrastructure for that environment in the state. So let's go ahead and actually do a Terraform plan and kind of see what this is going to do. Oh, I'm in the wrong environment. So, Terraform plan. And so right here, you can see it's refreshing the state. So what it's doing is actually going to Artifactory and pulling down the current state of what my infrastructure looks like on AWS right now. And you can see that I've got this module docker AWS.master. So it's going to actually, with the plus sign, that means it's going to actually create that. If it's a minus sign, it's going to destroy it, get rid of it. And if it's a tilde, that means that it's just going to make an alteration to it, but it doesn't need to bring it down. You might also see a minus / plus. That means it's going to destroy it first and then spin up that instance. But you can see that it's got the new AMI that I'm getting from Packer, which I actually forgot to show you guys that. One of the nice things about Terraform is I can go on to, it basically allows me to search AWS for whatever AMI I want and get the ID, and I'm just filtering it based on that AMI name that I made with Packer. So the Docker AMI dash whatever the version is, and it'll pull down that version.
What's AMI stand for?
Oh, geez, Amazon. Yeah, Amazon Machine Image.
Okay.
So it'll pull that down, and that's the one that's being used. And then it just kind of plugs that in. We're invoking that module that I created, and it's plugging that into the variables in that module. So it's setting that AMI, that instance type, that subnet, and then it's running that other code with this information that I've set. So we've seen that it's going to actually create a security group and the instance. So we'll go ahead and just do a Terraform apply. Normally, if you were configuring this stuff in a mutable way, it would take probably 10-15 minutes because it would still have to run those yum commands and run the installation of Docker on these nodes. But you'll see that this should probably take, I'd say, maybe 30 seconds. So it's a huge improvement there. And if you're using like auto-scaling groups on AWS, you basically just say, this is my AMI, and when you spin up, you're there. So you're already part of my entire infrastructure. You don't have to do any special configuration after the fact. And it really gives you a lot of extra time and space. So right there, it worked. And you can see I've got an output that's given me the IP address of that Docker host. So from here, I can actually SSH into that Docker host using the key that I stated I wanted to add into these hosts whenever it boots them up. So I can SSH into it. Take a second because of latency issues. Sometimes it actually is still bringing them up after the fact, but for the most part it is running. It's still doing some checks and making sure that the network is set up.
Yeah, have some jokes ready for this.
I think it's just Z shell.
Yeah, it's a Z shell. But if we actually look on AWS, I'm probably going to have to sign in. And check out the EC2, you'll see in the running instances this Tech Tailgate Docker host, and that's what I named it. So it's running, but it's still doing some of its status checks to make sure that everything's good. And that's the IP address that was actually output to me in the terminal there. So let's try it one more time. Okay. So now we're on.
Is there an admin interface at that IP?
One second. What's that?
Is there any, if you hit that IP in the browser, is there an interface or anything?
Not yet. Because this is just a Docker host. It doesn't have any containers actually running on it.
Oh.
And that's where your orchestration tools will come in, and Jenkins. Once we get like our Swarm clusters set up, those managers will be able to kind of handle pushing out whatever containers it needs out back into these. It'll see that it's got a new resource to work with and be able to start up these applications or these containers on these Docker hosts. But you can see I'm SSH'd into it, and I can actually do a Docker PS, and we'll see that Docker is running on here. And for an example, I'm actually going to clone down. Normally this would be handled by Swarm, but I'm just going to clone down the Selenium grid and run that on here. So you can see there too that we also have Git installed on here already. If I was to run JQ, you'd actually see that that's on there, in which normally this stuff's not on CentOS right out of the box. And as well the AWS CLI tools. Takes some minutes. Okay, so yeah, you can see that it's installed there. So I cloned down the Selenium Compose. We're going to go in here. You see your Docker Compose file. I'm going to make a change to it because it's going to try and put stuff in Splunk, which I don't want it to do. And then we can just do our Docker Compose up D. And that will bring up the Selenium grid. It'll pull it down from repository.cars.com and actually spin it up. So while this is running, this is actually going to take a minute because it's got to pull down the images. Does anybody have any questions?
Sure. Does Packer have anything that will allow derivative machine images to know that like a parent was updated? Say you're patching for something like Dirty Cow.
No. That is one thing that I have been working to solve. But in the case that we would want to maybe put out like a security update to all of our boxes using that base image, what we could do is it would be as easy as, let's say we want to first update all our Docker hosts, right? So we would build out that new base image with the security updates, and then we would go through and rebuild out a new image for using that new base. We'd build out a new Docker host with that security upgrade, and then we would just run Terraform apply, and it would automatically find that new AMI. It would spin up the new cluster that it needed to, and then destroy your old cluster and basically just swap them out for you. So, does anybody have any other questions? So this might take actually a minute. I didn't think this through fully.
How much time would you think you're saving by going down this route, the immutable route, over like the traditional way of doing this?
Quite a bit actually, because when we start getting into the cloud more and we're wanting to scale all of this stuff out, it's going to save an exponentially amount of time, like huge amounts of time, because every server now, instead of it taking 15 minutes to spin up and provision, it's now going to take a matter of seconds in comparison. And over time, that's who knows how many times we're actually going to spin up whole new clusters or anything like that with these security updates and stuff like that we need to do. And we'd see a lot less downtime as far as what our customers would see. They wouldn't even notice really a difference, because we would pretty much instantly have it up. and then bring all the other stuff down. Where if we're using something like Chef to do that, it would already be trying to, so it would spin up that instance, provision it, so we're waiting 15 minutes there, but while it's Terraform at that point, it's already thinking, okay, well, I'm done at this point, so I'm gonna already start tearing down the other stuff. So you kind of lose a lot of that in that situation. Yeah. So, and another thing with this is that using, you can still use Chef. We can still use our current configuration management tool that we have to provision all of these boxes. So Linux engineering, they don't need to really change what they're doing. They can keep going, working on Chef and making all these boxes. But it's just the way that we would actually package and build them out so that they don't change. And we would remove that call into the Chef server. So we don't want to run Chef client on these boxes because then that would make it mutable. It would mutate and change over time, and then you don't know, you can't roll back easily to something that you know for a fact worked. You know that version 1.2 worked with our infrastructure. Yeah, maybe it didn't have the best performance, but you know it worked, and nothing else changed. So Chef didn't change on that box. It didn't try and change a minor configuration. You have that state at all times.
I think there are some best practices that obviously we're going to evolve, like making sure that Linux engineering has a say in like the base image to make sure that all of the security configurations are there, all of the authentication mechanisms are in place, and then teams can build on top of some of the base images. But starting from just a publicly available base image is maybe not the best practice that we want to embrace.
Yeah.
Because you can find some stinkers out there.
Yes.
You don't want to build your production environment on someone else's base. There are also some best practices that will limit like how many how many depths, or how many steps do you want to have derivative images. So you have your base image, and then you may have like 4 layers. And if you're building a 5th image on top of something that has that many below it, if the base image changes, think of how many derivative images do need to change. And that's where you get the kind of maintainability question.
Yeah. And that's where we would have things like, for instance, on that base, we would have like our Splunk forwarders, we'd have Git, and everything like that, all that information. And then you would basically just build slight changes on top of that base to get it to where you want it to. Same as with Docker and how we're using the OpenJDK 7 Alpine 3.3 image. We're just making slight changes on top of that instead of trying to layer it too deep to where we'd have to continuously be remaking multiple things just to get your end state for your Docker image. Yeah. This is still taking a while. The internet up here is not the greatest.
Is it just pulling down all the images for all the extensions, like for all the browsers? Is that what it's doing?
Yeah, it's right now it's pulling down the Selenium Chrome node, but it's almost done.
Once extracting, I think you're using what, a T2 micro?
T2 medium.
It just looks like you're out of CPU credit. CPU ops.
And that's another thing that's actually pretty nice is that you can also scale these vertically just by changing, after you've built out the image, you can just change what instance type it is, and it will give you a lot more power. You can add that extra CPU, you can do all that stuff, and it still comes back to it's still gonna tear that instance down, but it's going to bring up the new instance first before actually tearing down the old ones, which is really nice. Okay. I think it's done-ish. All right. So now what we should be able to do is go to Chrome and go to the IP address of that box, which I don't remember what it was, 176. And port 444, and now we've actually got that entire grid. running on AWS through Docker with one instance. All right, how do we stop this?
Stop at the top.
You can't stop.